Okay, for these back 4 questions, we're doing trig word problems. And the trick to doing these is to make sure you can draw a diagram that looks like a right triangle so you can figure out all the other steps to our trig problems where you identify which trig function to use, set up the equation, and solve it. So this time step one is going to be to draw a diagram. And then the next step is all the same steps you took in the page before, where you're going to identify the trig function, you're going to set up the equation, and solve. Okay, so before we can do all that, like we did on the page before, we need to be able to draw a diagram and envision this right triangle that is in our picture. Okay, so let's go take a peek at these. Now notice that it says in some of these word problems, it says angle of inclination, angle of depression, angle of elevation, and in the bottom one, angle of depression again. So what these angle of inclination, angle of elevation, angle of depression mean, an angle of elevation is when you are rising up from the floor. So it's going to be an angle like that, going up from the flat floor up. That's also an angle of inclination. An angle of depression is going to be pressing down on a floor. So picture you have your flat surface and an angle of depression is going to be going down. So elevation or inclination is an angle going up, and an angle of depression would be pressing down from the flat floor going down. So keep this in mind as we're drawing our pictures for the next 4 problems. Okay, so a mouse sees an eagle atop a telephone pole. So picture our little mouse guy down here. Picture he's looking up to the top of a pole and he sees an eagle up there. We're being told that the angle of inclination, that's where the mouse is looking up to the eagle, and that angle of inclination is 52 degrees. So go ahead and draw your little mouse, draw your little eagle, and draw that 52 degrees. Then we're also being told that the mouse is 60 feet from the base of that pole. So that's that base right there. And then the height off the ground, how high off the ground is the eagle? That's our unknown, our x. So in reference to this angle of 52 degrees, we're being given an opposite, that's our unknown, and an adjacent is the 60 feet. So again, now that we've got this picture drawn and we can envision it, we're saying which trig function uses an opposite and an adjacent, and we realize this is going to be a TOA. So here we go, setting it up. The tangent of 52 degrees is equal to the opposite over the adjacent. And then we're going to multiply both sides by that denominator of 60. And into our calculator is going to go 60 times the tangent of 52. And we get 76.80 feet. So what we just found was how high up is the eagle. We found that this missing side is 76.80 feet. Okay, let's look at the second one. This is an angle of depression of 6. So a plane lands with an angle of depression of 6 degrees. If the plane is at an altitude of 24,000 feet, so picture this plane up here. He's at 24,000 feet. How far is the plane from the airport? So they want this missing hypotenuse. And so this 24,000 could go on either side. There's a couple ways to solve this one. But so if I am looking at this 24,000 as an opposite of my 6, and this hypotenuse is my missing side length, then we are going to go with an opposite over hypotenuse, and which trig function uses the opposite over hypotenuse? We've got a sine function. So we're going to go the sine of 6 degrees is equal to 24,000 over our missing hypotenuse, and we're going to multiply both sides by that x to bring up that denominator. And then we get the sine of 6 times x is equal to 24,000. And then we have to divide both sides by the sine of 6. So we get that x is approximately 24,000 divided by the sine of 6. Divided by the sine of 6. So we get 229,602.53. 60, and it's asking us to, how far is the plane from the airport? So we get 229,603 feet, but then it gives us this conversion of 1 mile equals 5280 feet. So technically we could do it in miles because we don't really say feet when we're talking about an airplane distance, right? So 229,603 divided by 5280. And so it's 43.49 miles. Okay. So we got the feet, 229,603 feet, but then we converted that to miles based on this little conversion that they gave us right here. Okay, but again, angle of depression went down. So when setting up this triangle, you had to figure out that was where that angle would be marked on the picture. Okay, next one is another angle of elevation. So let's go draw it. Little Jimmy stands with a taut string and it's stuck in a tree. He sees the kite with an angle of elevation of 71. If the string is 50 feet long, how high above Jimmy's head is his kite? So here's little Jimmy standing here. He's got the taut string and his kite is stuck up here in a tree. And it says that his angle of elevation is 71 degrees. If the string is 50 feet high, 50 feet long, how high is that kite stuck up in the tree? And so we're going to go with an opposite here. This is our opposite leg in reference to the 71 degree angle. And this right here is your hypotenuse. So which trig function uses an opposite and a hypotenuse? You got it. That's our sine function. So the sine of 71 degrees is equal to the opposite over the hypotenuse. Then we're going to multiply both sides by that 50. And we're going to get that x is approximately 50 times the sine of 71. And so we get 47.28 feet. And that's how high it is stuck up in the tree. Okay, last one is an angle of depression. So atop a 120-foot bridge, Joey sees a boat coming towards him in the river below with an angle of depression. So this bridge is 120 feet high, and he's looking at an angle of depression of 19 degrees. And how far is Joey from the boat? So here's the boat over here. Here's Joey. So again, when I say these angle of depressions can be done a couple ways, you can actually subtract 90 minus 19. So notice how you would get 81 for this little missing angle here. And you could use this 120 and you could find out how far is Joey from the boat as you're going for a missing hypotenuse. So this is adjacent over hypotenuse. But also, if you're going for this missing hypotenuse and you have this 19 and you know that this 120 works on both sides, you can actually do this with an opposite 120 over the hypotenuse. So it's the sine of 19 degrees is equal to 120 over the missing hypotenuse, or you could do it the other way. The cosine of 81 is 120 over the missing hypotenuse. So this problem could actually be done both ways. You decide which one makes most sense to you. I'm going to move this in so we have some workspace here. Make this 120 feet right here. All right, so I'm going to do the sine of 19 as equal to 120 over x. So are you guys starting to notice the fact that when we're dividing, these two basically change places? It becomes 120 over the sine. So sure, I can do the two steps, times x, divide by sine 19, divide by sine 19, but these two things end up switching places. And now it's dividing by the sine. So here I go, 120 divided by the sine of 19 equals 368.59. And this is in feet. And then what if we had done it the other way? What if we had done 120 divided by the cosine of 81? Just kidding. We were supposed to make it 71. Sorry, guys. Let's go fix this over here. You probably figured out my mistake earlier than me. 90 minus 19 is 71, not 81. And so that's going to make this right here 71. And now our answer comes out the same as 368.59. Okay, so whether you wanted to do it as this complementary angle, cosine of 71, or whether you wanted to do it the original angle of depression, the sine of 19, both of these will give you the missing hypotenuse. It's just two different ways to do it. Either way, this is how far Joey is from the boat. Okay, now, how are you feeling in general about these word problems? I hope you're feeling like you could try to draw the picture and try to pick out the trig function on your own. We're going to be practicing these all week. Okay, good job, you guys.